creek, so the next day found a lovely theropod fletching dinosaur footprint about that long. It's a matter of knowing what to look for.
Do you think eventually it could end up in the visitor center?
I wouldn't move it.
You wouldn't move it?
We have to, as an agency, do what we need to do to confirm the course.
I want to get cards like this, and I want to send you this material in the substation.
You know,
We found this part of Maryland, so we left it there. But later in the week, I found another one. I said, wait a minute. Wake up, wake up.
the next day, if you wanted to blow it off and put any of that stone, we have to rely on you, because I don't know what to do. And also tell me, I obviously will want to put something on it, but not put weight on it. So
Right.
See what this looks like for a second. And we are going to crank this up just a tad.
All yours. Think about it.
Yeah, because
Now taking it out, 112 million years it's been there, and we come along in 1 year and
Is that right?
Where's the other footprint?
Dig it out.
they have to about 11 o'clock when the crowd starts.
It's like trying to return after this.
Well, it's whatever you're allowed to do. Those are the two islands. We'll certainly do that, and if it's within your. Get under here. Let me try here.
I'm still terrible with like outdoor shots.
Oh, we spent.
That's a brand new shovel. They didn't take the label off it.
Here all the way along, I would have jacketed this like I would a whale skull. If this is a whale skull, that's typically what I do. Can't say is because we have to cut down through here, and it's extremely hard. Right. This sandstone, it's just brutishly hard. So. Again, the reason for this is that we want to ensure that we have a separator between the plaster that we're applying and the actual hematite layer. So I'm going to lay this down along here. We just drape it over the side. And this makes the next step a lot easier. Have it hang down further. I want to make sure that
Okay, hold that. Start tilting down some.
Okay, I'm holding my hand like this because what I want to show here is this very distinctive five-toed mammal track. 1, 2, 3, 4, 5. Just in that configuration. What's special about this track is that it is the largest mammal track on this surface, and indeed it's the largest mammal track known from the age of dinosaurs. During the age of dinosaurs, we've traditionally regarded most mammals as the size of rodents, rats and squirrels and so forth. It's very rare to find anything this big. I mean, this was an animal that was maybe the size of a badger or something like that. This was a big animal by mammal standards from the age of dinosaurs. Okay, well, this is a particularly interesting track. It's got 5 toes, very much the shape of my hand here, but this is the largest footprint that we've ever found and attributed to a mammal from the age of dinosaurs, and it really is a remarkable discovery. It's the largest mammal footprint on this slab, and the largest we know of from the. So we have 5 fingers and 5 toes. And so these are our Cretaceous ancestors, you might say. For a comparison, you could look at this track, which has 3 toes, and that is just typical of a modern bird, or the ancestor of a modern bird, which was a small theropod dinosaur, which would have made a track like this. You can actually see 1, 2, 3, 4, 5 toes. And that's the front footprint of a sauropod or a brontosaur. Okay, I'm holding my hand like this because what I want to show here is this very distinctive 5-toed mammal track. 1, 2, 3, 4, 5. Just in that configuration. What's special about this track is that it is the largest mammal track on this surface, and indeed it's the largest mammal track known from the age of dinosaurs. During the age of dinosaurs, we've traditionally regarded most mammals as the size of rodents, rats and squirrels and so forth. It's very rare to find anything this big. I mean, this was an animal that was maybe the size of a badger or something like that. This was a big animal by mammal standards from the age of dinosaurs. If you look at this track here, you can see all 5 digits, and or all 5 toes, if you like, and you can see a rim around the front of it where the footprint pushed forward. You can see the same thing here. So these are really typical mammal tracks. As far as size goes, they're raccoon size, I would say. We didn't have raccoons, as far as we know, in the Cretaceous, but something that size. So for comparison, if you like, here's a little 3-toed track like this, and that's typical of a bird or a small theropod dinosaur. In fact, the theropod dinosaurs are the ancestors of birds.
Yes. This is the first track that I spotted, because the rest of the slab was underground, and I quickly recognized that we have here a large nodosaur. This is a large armored dinosaur, and after we excavated the dirt in the back part of it that had infilled it, we saw first the footprint of a baby nodosaur, which was kind of a thrill. After this was ultimately cleaned off, we found out that there appeared to be a front and back footprints from the right side of the little baby that was walking along here. And to make matters more complicated, you might say, I then noticed that there are the footprints of let's say a chicken. Well, the feet looked about the size of a chicken feet, or a little smaller, where a small flesh-eating dinosaur walked completely around this footprint, and it adds a little bit of mystery as to what was going on.
Yes. Oh yeah, definitely. I think all of the previous finds have just been 1 or 2 isolated tracks representing one species. And here's a little one here that's sort of squirrel-sized track, mammal track.
Now you can almost call that one cute.
Yeah.
Well, what excites me about this slab found at Goddard Space Flight Center is that, unlike just finding the bones or teeth of a dinosaur, which show you a dead animal, this shows us the actual life and action of all this incredible diversity, from the flying reptiles to the large dinosaurs to the very smaller, tiniest perhaps dinosaurs, and 3, 4, 5 types of mammals.
Well, we're talking about a couple of square meters here that has approximately 100 footprints on it, about 100 tracks. At least half of them are made by mammals, and they range from the size of a squirrel to something maybe the size of a badger. And so we have at least 3 or 4 types of mammal tracks. Or, you know, it's a snapshot almost of a community of animals that were very active in this particular region for some reason. There was something that was attracting so many animals to this point in space. Well, the simple answer is there must have been something very attractive in this area for so many animals to come into this area. It may have been an area that was naturally very, very diverse, but quite possibly there was something about the substrate that was very rich in organic material or nutrients. There may have been a lot of coprolites, which is another word for fossil feces, that was distributed around here, and it attracted these small animals mostly to feed. So we have various different types of mammals that may have been trying to feed here. We have small chicken-sized dinosaurs, we have some pterosaurs or pterodactyls, and then we have evidence of a couple of large animals that were maybe just passing through, leaving their big footprints on this trampled surface. I mean, you could call this a trampled surface with hundreds of footprints in just a few square yards. Well, there are many surprising things here. One is just the sheer diversity. We have several major groups of animals represented. The mammals, the dinosaurs of different types of dinosaurs, the pterosaurs or pterodactyls, and also a bird. But as far as the mammals are concerned, we definitely have at least 3, if not 4 or 5 different types that we can distinguish. And we have enough of their footprints to be able to say, really for the first time, define what the feet of some of these different animals look like. But here we've kind of hit the mother lode. This is the largest specimen that we've been able to extract. And it came right here from the Goddard Space Center. We got it from its original position. So this is very exciting. This could be actually a key to understanding some of the other smaller finds that have been found in the area. So it brings everything together. Well, really what struck me more than anything is just that such a high density of small tracks. You can just go from one area to another and say, oh, look at this, and you know, and so on and so forth. So it's quite important in paleontology and science in general to have a good database. So we're going to be able to not measure 1 or 2 mammal tracks to compare with 1 or 2 in the rest of the world, but we're going to have a large sample, and we're going to be able to say, you know, how many of the small ones we have with the long toes, and how many of the medium-sized ones we have with the wide toes, and how many of the really large ones, larger than any we found before. So it's really just extracting, you know, paleontological data from the fossil record. It's being a good paleo detective. Really, this is the mother lode of fossil footprint discoveries in Maryland. It's really put the eastern seaboard, the eastern United States, on the map as far as fossil footprints are concerned. And the exciting thing is that it's new, and it's kind of a beginning, and I think it's going to lead to a lot of new publications and a lot of new understanding about the ancient history of this area of Maryland.